Hello and welcome to another video for SAT Math. Again, we are continuing with the previous topic, polynomial expressions. These are medium level questions. It is what is the quotient when this is divided by that. So I told you earlier in the video as well that you should know long division in order to complete all the questions on the SAT. You may be asked to find out the coefficient, or otherwise you can obviously do it with other methods. I'm teaching you long division. You may have done synthetic division or something, or comparison or something else, and you can pursue those methods. You can also do a bit of trial and error, and sort of, if you know what to do, you can go ahead and do that. What you simply need to do is, if you take answer option A, you think that's the correct answer, what you do is you multiply x squared plus 2x plus 1 with x plus 1 and see if you get the expression x cubed plus 3x squared. I am going to do a long division. So I'm going to multiply by x squared first to get x cubed. But I also get a complementary term that 1 into x squared gives me x squared. I subtract them and I end up with 2x squared. And then I bring another term down plus 3x. Now I need to multiply with 2x to get 2x squared. But I also get a complementary term that's 2x. Okay. And if you don't know long division, you should watch the entire video rather than just looking at this question. Okay, because long division is usually a tough process. So I get 1, that gives me x plus 1. I change the signs and I get everything cancelled out. So that should be my quotient, and that's the correct answer. A product is simple. So first you multiply with x cubed minus 3x squared plus 4x. And then I have a habit of writing them in the next line. So 2x squared minus 6x plus 8 with 2. Now I net them and I see that x cubed minus x squared minus 2x plus 8. So that should be answer option B. Okay. Then it says which of the following statements is the true of the polynomial. Okay. Now the easiest way of doing this question would be on a calculator. So I go to my cubic polynomial 1, 2, 1 and 1 if I want to find out the roots of this. Okay, so it's giving me one negative root, and what is it giving me? This is giving me an I at the end, which means that this is non-real or a complex root. Okay, so has a root at -1. We'll have to check if the other root should also not be real then. Okay, so it has one real root, and okay, this is also giving me local maximums and local minimums. It has a root at -1.75. So it doesn't have three real roots. The first statement is false. It has a root at -1. That statement is also false. So two only. Okay. Then there's a rectangular garden has an area of x squared plus 5x plus 6. The length of the garden is x plus 3. What is the width of the garden? So I don't know the width of the garden. So basically I have to divide x squared plus 5x plus 6 with x plus 3. Now there are various ways to do that. One of them is long division. Another is that I could also factorize this. I can see that the factors come out as x plus 3 and x plus 2 in the numerator. I've done them directly. You do your normal breaking the middle term and you get this. Question 5, what is the value? Now this is an interesting question. This is where I teach you comparison. Okay, I've taught you that in the lecture video as well, but this is about solving this question. So what do? You compare. What is the coefficient of this? Becomes 5x squared plus 5x plus 5. So whenever you have such a situation, what you can do is you say that since these expressions are equal, the coefficients must also be equal. So a is 5, b is 5, and c is also 5. So a plus b plus c should be 15. Some more medium questions on the way. Okay, let's do this one. Again, this looks similar. This time I'm subtracting, so x cubed minus x cubed plus 2x squared minus x squared plus 3x minus x plus 4 minus 1. X squared plus 2x plus 3. So a is 1, b is 2, c is 3. So I get a total of 6. A plus B plus C. What is the degree? Degree is the highest power. So 4 is the degree of the polynomial. If a positive integer b is divided by 5, the remainder is 3. What is the remainder if 4b plus 7 is divided by 4? So whenever you have these questions, you try to assume a number. What number when divided by 5 leaves a remainder of 3? So I'm going to say that examples of b will be 8 and then 13 and then 18 and so on. What I'm doing is I'm taking multiples of 5 and adding 3 to them. Okay. So now I want 4b plus 7. So what's 4b plus 7? That's 32 plus 7. That's 39. You could take any of these numbers. You don't have to take all of them necessarily. Okay. I'm just going to go back and say that 4 into 13 plus 7. It's 59 and so on. Now, what do I want? I want to divide these by 4. So 4 times 9 is 36. I also leave a remainder of 3. 414 is 56. That also leaves a remainder of 3. Okay, so I'm consistently leaving a remainder of 3. Okay, let's look at the next question. This one says if f of x is this, what is the value of f dot g? When I say dot, um, I think I should be multiplying these across. Okay, so x squared plus 3x plus 2 multiplied with x plus 1. So I get x cubed plus 3x squared. I'm first multiplying everything with x. So I get x cubed plus 4x squared plus 5x plus 2. And what is the sum of the coefficients? I think that's 13, 12, not 13. Okay, this one is about long division. Let's divide quickly. Plus x squared subtract 2x squared plus 3x. So 2x squared plus 2x. 1. I think that should be the answer. That is the end for medium level questions. I'll be back with another video. Thank you for watching.